If you already know of the task type and have now happened to meet a similar looking value task, then you are likely interested in knowing more about these types. And this article is my attempt at a quick explanation of the relation between value task and task types. Let's develop the concept step by step. A function that returns a task doesn't always execute asynchronously. It can sometimes finish synchronously. For example, consider this simple function that you are seeing. It doesn't execute asynchronously if x is less than 300. As you can see, the return type of this function is a task, and therefore it returns a task irrespective of the mode of completion. This means that there is an unnecessary allocation of task if the input is x less than 300. Well, this is a simple example that I gave, but consider the inefficiency associated with an ASP.NET Core application that has thousands of users calling async functions that happen to finish synchronously most of the time. So, before we come to the solution of this problem, we can agree on three main points. Firstly, an async function that returns a task can complete either synchronously or asynchronously depending on the conditions of execution, and possibly depending also on the state of the underlying hardware. And secondly, a task allocation will always take place irrespective of whether the function finishes synchronously or it finishes asynchronously. Each allocation takes place on the garbage collected heap because a task is after all a class. And thirdly, a heavy traffic on these functions can lead to an avoidable load on the garbage collector because some of these task allocations were really unnecessary. So we have a point of optimization. We have a possibility of optimization. We need to optimize an async code that returns a task and finishes synchronously sometimes. So such an asynchronous code can be optimized by returning a value task instead of a task. So value task is the solution here. Value task, as you must have guessed already, is a struct that can hold three types of data, but only one of them is used at a time. The three types are held in various internal data members of this struct, and let me list them. If you see the source code of this value struct, of this value task, one member is internal read-only nullable t-result underscore result. This member is used if the operation completes synchronously. This is a t-result, a direct member that holds the result of an synchronously completed operation. So underscore result will hold the result if the operation completes synchronously. And secondly, there is another member called internal read-only nullable underscore obj. This member, it stores a task. This task is for the case of asynchronous. These two members, they were originally present in this value task, but later on a third member was also added. That member is also stored in underscore obj. This obj can store an I-value task source. So underscore obj can either store a task or it can store I-value task source. This I-value task source was added later. It was added for pooling and reuse of resources. Basically, it is for optimizations, and that is beyond the scope of this article right now. You will have to go through the documentation for more on I-value task source. So at present, we can easily see that a value task can store the result directly to avoid the overhead of creating a task. Hence, we can say in nutshell that a value task is a multi-purpose struct that can avoid the overhead of creating a task if an operation completes synchronously. Now the next question is, how do we know which member contains the data of interest? Value struct, value task can hold three types of data. Now how do we know which is our data of interest, which is the active member? Whether the data is in underscore obj or is it in underscore result, how do we know? So if you see the source code, then there are basically few rules for that which are used internally only. You do not have to be concerned about these rules, but I am giving them so that we can have some sort of curiosity. We might be having some curiosity. So let's try to see those rules also. If underscore obj is null, then the operation has completed synchronously and the result is contained in underscore result. So this is the first rule. So internally we check if underscore obj is null, then the data is contained in underscore result. And if underscore obj is not null and another member called internal read-only underscore token is non-zero, so there is a third member also underscore token. If it is non-zero, then underscore obj contains an I-value task source and underscore token, it contains a token associated with it. So a non-zero token means that obj is storing I-value task source, and if this underscore token is 0, then underscore obj it contains a task. So these are the rules basically that determine which is the active data member. Now value task, it has a few limitations also. So task is the mostly used one because value task has certain limitations, and let me explain those limitations also. A value task is recommended only if your code will await it once. Multiple awaits is not allowed because value task has pooled resources. So if your code has only one await condition, then you can use value task, and especially use value task if you expect heavy traffic on a function that returns a task. Now in most of our ASP.NET Core, a value task is likely to be useful. And for more detail, please do refer to the MSDN documentation. Let's now see the things practically. Open the Solution Explorer and locate the program.cs file, double-click to open it. The same function that we started, in that case we have changed the return type to value task. The function calculate square executes asynchronously only if the input is more than 300, otherwise it executes synchronously. And inside main, we make a call to calculate square and store the result in a variable vt, and then extract the result from vt to store it in an int. So put a breakpoint as you see here and run the code by passing a value of 50 so that the code executes synchronously. We observe that underscore result, it contains the output and obj is null, which verifies that a task wasn't allocated and optimization has indeed taken place. We can similarly run the program by passing a value of 600, a value that is more than 300, so that the code will execute asynchronously. We observe that now underscore obj contains a task because the operation was asynchronous. Thus we have seen practically that a value task can hold data for both the scenarios. Thank you.